100. 125. 100. 150. 175. 275. 225. 150. 275. 175. 300. 400. 550.
'Sharing is probably the last thing I want to think about when I've got a candy bar. But sharing can make things a whole lot easier when you're adding numbers.
I think I'd rather share the candy bar.
No way! I'm thinking about the sharing for ease method of adding. I'll demonstrate this with candy bars. Imagine each bar is divided into 10 equal sections.
So a candy bar is a 10, and each of its sections is a 1.
Yeah. Say we had 28 plus 46. Remember, it's always easier to add an even 10 to a number. So I'm going to share some of the ones from one number to make the other number an even 10. 28 is the same as 2 10s and 8 1s. 46 is 4 10s and 6 1s. 28 only needs 2 more ones to be a 10, so I'll share 2 from 46 with a 28. Now, by sharing, I have made the easy problem 30 plus 44. I can add that number in my head. The answer is 74.
Well, I want to try one of those. 24 plus 57. Now, it would only take 3 more ones for the 57 to be an even 60. If the 24 shares 3 of its ones, that leaves us with 21 plus 60. Easy, 81.
Do this problem with me. 47 plus 45. How many should I take from the 47 to share with the 45?
Well, 5 will do it.
That's right. Sharing 5 will leave 42 plus 50, or 92. I think we should try one using only the numbers this time, don't you?
Well, then can I eat the candy bars?
No, not yet. Try this problem. 36 plus 49.
Well, we could have the 36 share 1 with the 49. And that makes the problem very simple. 50 plus 35 is 85. $53. $92. $61. $92. $65. $71. $74. $92. $53. $62. $82. $93. $84.
Stepping up or down is another method we can use to make subtraction problems easier. To help you get a picture of the idea, think about climbing stairs with a friend. Each step is numbered from the bottom up. At first, your friend is 4 steps higher than you. If you both go up 1 step, your friend is still 4 steps higher than you. If you each go up 2 steps, your friend will still be 4 steps higher than you. As long as you both go the same number of steps in the same direction, the distance between you stays the same. Suppose your friend runs faster for a little bit. By the time she is at step 87, you're only at step 49. You can find out how many steps ahead she is by subtracting 49 from 87. That's not an easy subtraction to do in your head.
Well, I remember when we were working with addition, working with even tens always made things easier. Is there some way that can work with subtraction?
Sure. 49 is really close to the even 50. All you'd have to do is go up 1 step to 50, and you'd have an easy subtraction.
Well, yeah, but wouldn't that mess up the answer?
Not if your friend went up 1 step the same as you did. Remember, then the distance between you would be the same.
Okay. Well, my friend should go up 1 step to 88. Well, now I get it. My subtraction is 88 minus 50. That's easy. She is 38 steps higher than I am.
Here's another problem where stepping up will help us. 43 minus 28. Notice that 28 is just 2 steps away from the easy to subtract 30. Since I'm increasing 28 by 2, I must increase 43 by 2 steps, making it 45. Now that's a simple subtraction. 45 minus 30 is 15.
You're right, that is easy. Now, did you say that stepping down would help too?
Sure. We'll take 95 minus 61, for example. It's easiest if we make the number we're subtracting be even 10. 61 is only one step above 60. Since I'm stepping down one step to 60, 95 must go down one step to 94. That gives us 94 minus 60. The difference is 34.
Here's one more stepping down problem that we can do together. 86 minus 32. Now, we could just step down the 2 steps to an even 30. Then 86 goes down 2 steps. So we subtract 84 minus 30, and we get 54. Left-to-right addition is an easy way to add numbers in your head that helps you become quite fast.
We know that you already know how to add, but you probably do it in the opposite direction.
And that's okay. The traditional method works great. The only problem is, when you use it, you need to remember all these little in-between steps.
And you know, all those little in-between steps, they take time.
One reason left-to-right addition is so much faster is that our eyes are accustomed to reading in a left-to-right pattern. We read like that every day.
For instance, if I were going to sound out a big word like brontosaurus. Oh, hi! I'd start on the left and work to the right. Brontosaurus.
That's right. That's the way it works with words. Left-to-right addition makes even more sense when you think about the way numbers work. Because after all, the numbers to the left have the greatest value. So you add those first.
You know, if you were going to give me 2 big bags filled with money...
I don't think I'd do that.
Well, let's just imagine that you did.
Okay.
One bag was filled with coins, the other bag filled with bills. I'd sure count the bills first.
Of course you would, because the bills have the greatest value. That's left-to-right addition. I like to think of left-to-right addition as just easy addition facts lined up close together. Here's a problem that shows you what I mean. 4,231 plus 2,638.
Don't be fooled by its size. It's really just 4 plus 2, 2 plus 6, 3 plus 3, and 1 plus 8. Breaking big problems into smaller ones makes them easier to handle.
And the thing that really speeds us along is that we get to start speaking out the answer before we're even finished figuring the problem.
Huh?
Well, you see, if we're adding from left to right, the first digits we add together are the first part of the answer that we say. And that'll make sense in a minute. For now, find the place value of the numbers furthest left.
Okay, let's see. Place value. We have ones, tens, hundreds, thousands. The 4 and the 2 are in the thousands place, so we say 6,869.
Great! Let's look at another. 135 plus 243.
Okay, the 1 and the 2 are in the hundreds place, so when we add them, we say 378.
Do you think they're adding them with us?
I don't know.
Add the numbers along with us in your head and say the answers as we do.
Here's a good one. 621 plus 274. Okay, 6 and 2 are in the hundreds place again, so we say 895.
Are you ready for a bigger one?
Sure they are.
We'll try this and we'll help you out. 2,724 plus 5,162. Now let's see, we have hundreds, thousands. Our 2 and our 5 are in the thousands place. So we say 7,886. Not bad.
Yeah.
Let's do one more together. 3,285 plus 1,402. We're in the thousands place again, so we say 4,687.
57. 86. 97. 56. 89. 57. 84. 79. 63. 89. 977. 77. 639. 859. 587. 3,487. 9,627. 6,589. 8,639. 4,897.
You know that sometimes two digits add to 10 or more, like 35 plus 18. No problem with the 3 and the 1 in the tens column, that's 40. But 5 and 8 make 13, and that's too much for the ones place.
Well, whenever that happens, I just back up and fix the previous number. The 110 from the 13 combines with the 4 tens we already have to make 50. And then the 3 from the 13 stays in the ones column. Let's do a few together and I think they'll get the idea. 26 plus 17. 2 tens and 1 10 are 30. 6 and 7 are 13.
Whoops. Back up and fix the last number. 43.
Here's another. 28 plus 43. 60.
Oops. 71. I just do the fix-ups by writing right over the top of the last number. But if I'm just saying my answers aloud, I just correct what I said before.
Shall we try a longer problem? 491 plus 237. Now let's see, we're in the hundreds place, so we say 728. How about one more together? 5,246 plus 1,329. This time we start with the thousands place, so we have 6,560.
Oops. 75.
96. 80. 62. 90. 82. 82. 67. 65. 85. 81. 616. 617. 1,158. 1,184. 6,187. 7,990.
'If you like going to the arcade and playing the video games, you're probably already pretty good at counting quarters.
Yeah, and knowing how to count quarters can really help you with your math. Here's $3 in quarters. Count them with me. 25, 50, 75, $1. $1.25, $1.50, $1.75, $2. $2.25, $2.50, $2.75, $3.
Be sure to notice that repeating pattern of 25, 50, 75, and 100. You can use that pattern and think about quarters to help you add in your head. Suppose you had 125 plus 50.
Well, I would think of that like $1.25 plus 2 more quarters. Well, we have then $1.50, $1.75. My answer, 175. Let's see how thinking about money can help add 75 plus 75.
Here's a couple of ways I might handle that. First, we could just use that same pattern and count on by quarters. Since we know that 3 quarters is 75, we start with the 75 first and count on 3 more quarters, saying 75, $1, $1.25, $1.50. The answer is 150.
Now the second way of looking at it may seem even more natural to you. You take the quarter from the second 75 cents to make the first group into $1. Then you see that the remaining 2 quarters are 50 cents. So you know you have $1.50.
Let's do a more complicated problem with them, like 325 plus 50 plus 75.
Well, that's not hard when you remember money. Right away, I'd put the 75 cents with the quarter from the $3.25 to make $4. Well, then we have 50 cents to add on, making $4.50, or 450 if it's not money we're dealing with.
When we first learned to multiply, we started with the facts for multiplying by 2. So doubling a number is easy. And it's even easier when we build on what we've learned about breaking numbers apart and computing from left to right.
The thing I like to double most is the dips on my ice cream cone.
Double fudge is the best. Anyway, about doubling numbers. Say I wanted a double dip ice cream cone.
Each dip costs 73 cents.
An easy way to double the price is to think of 73 as 70 plus 3. Doubling 70 is 140. Then doubling 3 is 6. Now add 140 plus 6. So 73 doubled is 146, or $1.46.
You know, I think we ought to stop for hamburgers on the way home.
You sure have food on your mind today.
Let's see, I think they cost $1.64. If we both get one, then we double the dollar, make it $2. Then 2 times 60 cents is $1.20 more, or $3.20. Plus 2 times 4 is 8. Add that to the cost of the $3.20. So 2 hamburgers will cost us $3.28.
While he's doing that, let's double a large number like 4,325. Our problem would be 2 times 4,325. 2 times 4,000 would be 8,000. 2 times 300 is 600. That's 8,600. Then, like quarters, 2 25s is 50. So you have 8,650.
$64. $86. $264. $150. $30. $54. $166. $508. $650. $1,238. $482. $6,284. $1,056. $5,000. 8,048.
As the dividend gets more complicated, it may help to break it in additive parts.
This is slightly different from the expanded forms we have used before because we break it into parts that we can use easily with multiplication facts we already know.
Let's show what we're talking about with an example.
Here's a good one. 128 divided by 4. Now, if we expanded the dividend, it would be 100 plus 20 plus 8. But I see a better way of breaking it up. I'll break it into 120 plus 8. Those numbers are easy to divide by 4. Remembering the divide by multiplying lesson, we can say 4 times what is 120? Well, 4 times 30 is 120. We write our partial answer, 30, in the quotient. Then ask, 4 times what equals 8? 4 times 2 equals 8. So we add 2 to the 30. Our final answer, 32.
Let's try that process again with 816 divided by 2. With the divisor 2 in mind, I'll think about breaking the dividend into 800 plus 16. To divide 800 by 2, I ask, 2 times what is 800? Since 2 times 400 is 800, I write 400 as my partial answer. Then I ask, 2 times what is 16? Well, 2 times 8 is 16, so we add 8 to the 400 for a final answer of 408.
Now for 639 divided by 3. Considering my divisor 3, this would be easiest as 600 plus 30 plus 9. 3 times what is 600? Well, 3 times 200 is 600. Write the partial answer 200. 3 times what equals 30? 3 times 10 equals 30. Adding the 10 to the 200, we have 210. 3 times what is 9? 3 times 3 is 9. So last, we add the 3 to our 210 for the final answer, 213.
Let's do one more.
Well, okay. How about 486 divided by 6?
Okay, let's see, with facts of 6 in mind, I'd take 480 plus 6.
Well, that's a good choice. Since 6 times 8 equals 48, the partial answer for 480 divided by 6 is 80. Then divide 6 by 6, and that gives us one more to add on. Our answer, 81.
$24. $32. $21. $34. $27. $71. $42. $104. $107. $41. $93. $43. $209. $41.
$78. $67. $88. $76. $58. $497. $384. $967. $595. 471.
Let's take a look at compatible numbers.
Compatible numbers. That's an interesting idea. I know what compatible people are.
Well, compatible numbers are two numbers that add to a nice round number. I mean like 10, 100, or 1,000. Well, we're going to be looking for compatibles that add to 10. That will make adding columns of numbers easier.
When we look at a column of numbers, we want our minds to pop those combinations together just like two magnets click together.
When we recognize tens, we can count them in our head. And then we just add on any numbers that are left over.
Here's a problem. Let's see how it works. I like to use my pencil to cross off the numbers as I use them. Well, that way I don't get confused. Right off, I see a 5 on the top and the lower 5. That's 10.
And I see a 3 and a 7 close together. Well, that's 20.
And then there's a 6 and a 4 way apart. That's 30.
Well, no other numbers left, so our answer is 30.
Hey, this is kind of like hide and seek.
Yeah, it is, isn't it?
5 and 5 are 10. 3 and 7 make 20. No more 10s, so 29, 33. Sometimes if I don't want to count out loud, I keep track of the number of 10s on my hands.
Here's another. 4 and 6 are 10. 2 and 8 make 20. No more 10s, so 25, 29.
This one's a little longer. 1 and 9, 10. 5 and 5, 20. 4 and 6, 30. No more 10s, so 38, 41.
When I get to the end of my groups of 10, I look at the numbers that are left to see which is the biggest. I like to tack on the biggest number next, and then any smaller numbers last. It's easy to add a big number to an even 10. And then I only have smaller numbers left to deal with.
Ah, yes. Answers for the drills. Oh, right here. $28 would be the answer. $37. Ah, 39. this one's 36. 36 would be the answer. This one would be 40. Oh, my little chickadee, your eyes are like 39. I can believe that it was a 46.
Lots of people find it easier to add than to subtract. So when I found out that you could get the answer to a subtraction problem by adding, I wanted to find out how. And you know, it really works.
Well, how can we subtract by adding?
Well, you may have done it already when you were first learning how to subtract. One easy way to solve a problem was to start with a smaller number and count on until you reached the larger number. Well, say you had a number like 9 minus 5. So you said 5, and then you counted on 6, 7, 8, 9. That was 4 counts, so the answer was 4.
Well, yeah, I forgot I used to do that. But how can that help me now?
Well, you can use the same idea with larger subtraction problems. You know how easy it is to count on by tens. If you start with, let's say, 23, for example, and count on by tens, you'd have 33, 43, 53, 63, 73.
Yeah, we've been through that before. But how can that help me subtract?
Well, let's take a subtraction problem, and I'll show you how we can add on to get the answer. Okay, 72 minus 45. We start with a smaller number, 45, and add on until we get to the larger number, 72. We just keep track of how much we add, and that's our answer.
Show me how you do it.
I start with 45 and count on by tens until there isn't any room for another 10. I'll keep track of how many tens I use on my hand. Okay, here we go. 45, 55, 65. That's 2 tens. I can't use more tens because that would add to more than 72. So now I add on the number of ones it takes to get to 72. Now, 5 ones to 70, and 2 more to 72. That's 7 ones. 2 tens and 7 ones is 27.
Would you do another one while I watch?
Sure. 86 minus 35. Start with 35. 45, 55, 65, 75, 85. And 1 more to 86. 5 tens and a 1 makes 51.
Okay, I think I'm ready to try one out.
Okay, how about 49 minus 27?
27, 37, 47. Well, that's 20, plus 2 more to 49. That gives us an answer of 22. I think I'm going to like subtracting by adding.
Okay, one last one together. 60 minus 23. Start with the 23. 33, 43, 53. 7 more takes me to 60. 30 and 7 is 37.
One. 13. 38. 55. 41. 48. 37. 19. 59. 35. 58. 46. 35. 52.
Now we're going to give you some strategies to help you do more of your math in your head instead of writing it down on paper or punching it into a calculator. The more we can handle in our heads, the faster we become.
When we can do things fast and easy, it seems more like a game and less like work.
I like the sound of that.
Me too.
This lesson is called Round and Adjust. We call a number a round number when it's an even 10.
You know how easy it is to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90.
I think we get the idea. Now adding by even tens is really easy too. So we're going to take advantage of those easy operations that you already do so well.
Here's a problem. 28 plus 35. Not too hard, but it would be a lot easier if one of the numbers was an even 10.
Take a look at the hundreds chart a minute. When a number is only 1 or 2 steps away from an even 10, there is an easy adjustment we can make. Suppose we just increased our 28 by 2 to make it 30.
That makes the mental addition easy. 30 plus 35 is 65. Now all we need to do is readjust our answer by the same amount. We increased one of our numbers by 2, so we must decrease the answer by 2. Our real answer, 63.
Let's try this one. 57 plus 19. Now 19 is just 1 away from an even 10, so we'll increase it by 1 to make it 20. Mentally add left to right. 57 plus 20 is 77. But now we need to readjust the answer, decreasing it by 1 to make it 76. Try this one. 39 plus 16.
Psst. Are either of the numbers close to an even 10?
Well, if we increase our 39 by just 1 step, it would become 40.
That's an easy mental addition. 40 plus 16 is 56. Now we must readjust our answer, decreasing it by 1 to 55.
Here's another. 23 plus 18.
Is there a number close to an even 10?
Well, yes, 18 can be increased by 2 to make it 20. 20 plus 23 is 43. Now readjust the answer. Decrease it by 2 to make it 41.
Which of these numbers is close to an even 10? 728 is. Let's increase it by 2 to 730. Adding left to right, we get 794. Since we increased by 2, we must decrease our answer by 2. The real answer is 792.
$85. $71. $83. $86. $64. $94. $153. $274.
Well, suppose we had 190 plus 136. Well, I just round 190 up by 10 to 200. Now we can mentally add 200 plus 136. The answer? 336. But don't forget to adjust the answer back down by 10. Our real answer is 326. Here's an example with thousands. 2,454 plus 2,800.
The 2,800 is just 2 hundredths away from 3,000. So we'll round it up by that 200 and have the easy mental problem, 2,454 plus 3,000. Well, that is 5,454. But then we need to adjust the answer back down by the 200, making it 5,254.
When I'm doing the rounding in these problems, I don't make the adjustments on paper. I just do it in my head. But before I write the answer down, I remind myself to adjust it back again.
$413. $316. $527. $652. $455. $6,206. $5,415. $3,034. $5,363. $4,468.
Have a look at the hundreds chart again. We've been working with numbers that are just one or two places less than an even 10. But we could use the same principle if a number was just one or two more than an even 10. We just have to remember that if we adjust a number down, we have to readjust our answer up again.
46 plus 21. Notice the 21 is only one step greater than the easy to add 20. If we decrease 21 to 20, we can add it in our head. 46 plus 20. 66. Now we must readjust our answer back up one to 67.
Here's one that has a number only two steps more than an even 10. 62 plus 27. Now we should decrease the 62 by 2. Simply think 60 plus 27. That's 87. Now readjust your answer back up by 2. 89.
Simple.
Four. 5. 8. 6. 7. 6. 7. 3. 50. 300. 400. 50. 90. 800. 100.
As soon as Marcia gets here, we're going to start talking about a new method. Where'd you beam in from?
The outer reaches of the multiplication galaxy. I was just learning this great way to multiply by adding.
Great. How does it work?
Well, to make this work, you've got to have your basic facts memorized.
Right. That always makes multiplication a lot easier. I've been brushing up on them.
Here's the addition method of multiplication. I call it that because I break one of the numbers into its add together parts. We'll take a look at 42 times 6. Break the larger number 42 into its expanded form, 40 plus 2. Then multiply each part by the 6. Starting from the left, 6 times 40. Well, that's 240. Remember the intermediate answer, 240, while you do the next part.
Well, it might help to say the 240 to yourself a couple times to help you remember.
Okay, 240, 240. Now, multiply 6 times 2. Well, the answer to that is 12. Then you add 12 plus 240. The answer is 252.
Whoa, I think I'm going to need a few practice problems to get the hang of this.
Okay, do 37 times 5.
You said the key was to break the larger number into parts. Okay. 37 becomes 30 plus 7.
Now, multiply each part starting on the left.
Well, 5 times 30 is 150.
Remember 150 while you multiply.
Okay. 5 times 7, 35.
Add 35 to 150.
185. Hey, that's not so tough.
Yeah. Here's another. 54 times 8. Now you're going to think about breaking 54 into 50 plus 4. But we can just look at the 54 and remember that the 5 means 50. So, 8 times 50 is 400. Remember 400. Then look at the ones place. 8 times 4. Well, that's 32. Add 400 plus 32. And your answer is 432.
208. 416. 238. 405. 335. 255. 438.
Do you remember the compatible tens we worked with in addition?
Well, those were the dancing couples, weren't they?
That's right. Well, there are also compatibles in multiplication. Those are factors that multiply together to give a nice round number. Well, like 10, 100, or 1,000. 10 has just one set. That's 2 times 5. But 100 has several sets to watch for.
Well, I can think of 10 times 10. What are some others?
Well, there's also 4 times 25, 2 times 50, or 5 times 20.
Oh.
The compatibles for 1,000 are the same as the ones for 100, except that one of the factors has an extra n0. There's 10 times 100, 4 times 250, or 40 times 25, 2 times 500, or 20 times 50, and 5 times 200. Now, if you have a train of factors to multiply together, look for the compatible factors and multiply them first. You can even rearrange the factors in the problem if that makes it easier to think about. Here's a problem to see how it works. 5 times 6 times 5 times 7 times 2 times 2. If you tried to multiply each factor in your head as you come to it, you'd probably give up. But if you watch for the compatible numbers and multiply them first, the intermediate answers are much easier to work with.
If we match up 5 times 2, that's 10. We can match another 5 times 2 for a second 10.
So now you have another pair of compatibles. We can rearrange the factors so it's easier to see that we have 10 times 10, making 100, and 6 times 7, or 42. Now, our remaining problem is 100 times 42. The answer to our long train is 4,200.
That wasn't bad at all. The key was multiplying those compatibles first.
Well, let's practice on another one. 9 times 5 times 20 times 4. Do you see any compatible factors?
Now there's 5 times 20. Well, that makes 100.
Good. So we'll start with them. Next, we'll multiply 9 times 4. That's 36. We'll end up with 100 times 36 for 3,600. Sometimes you can factor apart one of the multipliers in order to use part of it for a compatible. Suppose I had 2 times 13 times 15. There are no obvious compatibles. But if I factor 15 as 3 times 5, I can use the 5 with the 2 to make 10. Now, 13 times 3 is 39. And taking that times 10 is no problem. The answer, 390.
160. 700. 3,500. 24,000. 4,300. 56,000. 14,400. 7,200. 3,600.
Do we need a new white balance? Yeah, I need to run those color bars too.
Yeah, I know, that's all right.
Which tape? You got the tape and the camera and everything's ready? Okay.
Are these are for today?
Yeah, those are the ones.
Okay.
What do we got?
We need a new white balance.
Uh-oh. Division.
So what?
I don't know why, but I've always had such a hard time with division.
Oh, well, a lot of people don't like division because they think it's more difficult. But, you can always take a division problem and make it a multiplication problem.
Huh?
Well, yeah, like, suppose you had a division problem like 80 divided by 10 equals what? Well, you just turn it into a multiplication problem. You say 10 times what equals 80. Well, 10 times 8 equals 80,
Yeah.
right? So 8 is your answer, the quotient. So 80 divided by 10 equals 8.
Okay, let's see. If I had a problem like 100 divided by 5 equals what? I'd re-say it as 5 times what equals 100.
Right.
Well, 5 times 20 is 100. So 20 is the answer.
Uh-huh.
Hey, that does make it a little easier.
Yeah, or like suppose you had a tougher problem, like 320 divided by 8. Try that one.
All right, 320 divided by 8 would be 8 times what is 320. If I set aside the 1 0 in the 320, I'd have 8 times what is 32. Well, that's 4. And then I put the 0 back on. 320 divided by 8 is 40.
Right.
Hey, that works. Should we make it a take?
Sure. Okay.